to Octave, where we'll continue in our study of for loops and arrays and conditional statements. All right, so let's start with the for loop. The goal is to add up the first 100 numbers. So let's write a small Octave program to add up the first 100 numbers. So first, let's start with a variable and set it equal to 0. Now we're going to add to this variable s all the numbers from 1 to 100, but only one at a time, not in one line or one step. So for I equals 1 to 100, s equals s plus I, and for so this displayed all the numbers, and we saw that the answer was 50-50, but let's rewrite it. So let's start again with s equals 0, and for I equals 1 to 100. This time we'll use a semicolon. S equals s plus I semicolon. And the for loop. Now there's no output, but the value for s has been updated. So if we display s, we see the sum of the first 100 numbers is 5,050. Okay. Now let's say we wanted to add up the first 100 even numbers. Well, the same idea. Start s equal to 0. And we need a for loop. We need 100 numbers. Now, this time we'll add, instead of I, we'll add 2 times I. So instead of just adding 1 plus 2 plus 3 plus 4, we're going to add 2 plus 4 plus 6 plus 8. All right, so let's end the for loop. And let's display s. And we see the sum of the first 100 even numbers is 10,100. All right, so let's now combine arrays and for loops. So as we add up the first 100 numbers, why don't we store the partial sums in an array? So let's start an array, and let's let x equal zeros, 1, 100. All right, so just to see what we have here, for I equals 1 to 100, display x of I, and 4. So what we just did is we went through every number in our array x, and we displayed the value in the ith position. Now let's store in our array, let's change it to a smaller array of only 10 numbers, just so we can see the output a little better. So let x equal 0s, 1, 10. Okay, now let's fill this array with the numbers from 1 to 10 using a for loop. So we want this to be a 1, 2, 3, 4, up to 10. For I equals 1 to 10, x I is equal to, so what do you think would go right here? So the answer is x of I equals I. And 4, so let's do this loop. All right, let's display x, and we see we have the numbers from 1 to 10. How about if we wanted to go from 10 to 1? Let's try that backwards. So let's start over, hit the up arrow, and reinitialize x. For I equals, or we could try this, 10 down to 1, x, the ith element of x, is equal to I, and 4, let's see x. Oh, it didn't seem to work. Maybe this extra line there, let's try this again. So x of I is equal to I, and 4. Nope. All right, so Octave doesn't like this notation, and that's because we're not using it correctly. So you can't simply reverse the numbers in a for loop. You need to do something a little bit more careful. So, for example, something like this perhaps. For I equals 10 to 1, step size -1. X I equals I, and 4. All right, so it doesn't like this either, but we don't actually have to reverse the for loop to accomplish getting a 10 and a 9 and an 8 and a 7. We can actually do this by hand if we just think a little bit more carefully. All right, so let's start over. So x is an array with 10 zeros. So for I equals 1 to 10, we want, when I is equal to 1, we want the number 10 to be there, right? So when I is 1, we would say 10 minus I. So 10 minus I would give us a 9. But we want there to be a 10 there, right? So we would add 1. So let's try this out. We're basically saying 11 minus I, where I goes from 1 to 10. When I is 1, you'll get a 10. When I is 10, you'll get a 1. And 4. Let's see what x is. And as you can see, we accomplished it. We were able to get x to be the reverse. Okay. Now, how about filling up x with random numbers. So there's a function called randi, which gives you random numbers. So randi of 4, you see what it's doing? It's giving us a random number between 1 and 4. As opposed to rand, which gives us a random decimal between 0 and 1. Okay, so let's try this. Let's fill an array with 10 random numbers. So let's try that out. Alright, so let's start x equals zeros. Start with 10 zeros. Okay, now we definitely need a for loop, unless you want to do this by hand. So for I equals 1, 2, 10. So the ith element of the array is equal to a random integer from 1 to 100. So randi of 100 is going to choose for us a random number from 1 to 100, and we're going to store it in the array x. Okay, so let's see what x is. And as you can see, we got this number. Now if we run this again, you see we get totally different numbers. So the random number is a one-time deal, and each time you run the function, you get a brand new random number. Okay, suppose we want to add up these random numbers. Well, we could do it two ways. The easy way is to use Octave's built-in commands to just find the sum of 10 numbers. The hard way is to write a for loop to do this. So let's try the hard way with a for loop. Once again, s is 0. And we simply go through the list and add each term to s one by one. For I equals 1 to 10, s equals s plus. Now we want to take the ith element of the list, so x of I, and 4, and there's our sum, 296. Now suppose we only wanted to add numbers that are even. So only add the numbers of x that are even. How would we do that? Okay, well, we need something new, which is called an if-then statement. So let's give this a try. If, let's let x equal 2. So we know x is 2. If x is greater than 3, display yes, it is greater than 3. else display no, it's not. And let's end our if block. And this is correct. No, it's not greater than 3. What happens if we say x greater than 3? It says the answer to that is 0. Let's say we say x is less than 3. It says the answer to that is 1. What we have here is what's called a Boolean variable. A Boolean variable is either true or false. So the word true is 1, the word false is 0. And you could store these as variables. For example, z is equal to x less than 3. So z is holding a 0 or 1, and it's holding a 1 if the statement is true. It's holding a 0 if the statement is false. But remember, the word true and false really means 1 and 0. Okay, so we want to write a little loop to add only the even numbers of x. Okay, well, let's give it a try. So here's x. Well, I think we lost our x. So let's fill x with random numbers again. So x equals zeros, 1 to 10. For I equals 1 to 10, x of I equals rand I 100. And 4. Okay, so x is a list, an array with 10 random numbers, and we only want to add up the even numbers here. Okay, so s equals 0. For I equals 1 to 10. Now we only want to add to s if the number is even. So if the ith number of x, the ith element of x, so in order to test if a number is even or odd, use the remainder function. Let me explain this one carefully first. All right, remainder of 10, 2. 10 divided by 2 has remainder 0. 10 divided by 3 has remainder 1. 10 remainder divided by 4 has remainder 2. But particularly, if you look at odd and even numbers, you can test out if a number is even or odd by dividing by 2 and seeing if you get a 0 remainder or a 1 remainder. Okay, so we're only going to add the number if the remainder divided by 2 is 0. Okay, so we have x, s is 0, so let's start. So for I equals 1 to 10, now if the remainder of x of I, so if the ith number in the array x is after dividing by 2 has remainder 0, so if the ith number is an even number, so equals 0. So if this is true, then we want to add x of I to s. So s equals s plus x of I. If it's not true, if it's an odd number, we won't do anything. I will just go on, increment to the next value. Okay, so let's end our if. And let's end the for loop. Now let's look at our sum. And the answer is 178. Which looks correct looking at our values here. So this concludes our review of for loops and arrays combined.